Let's learn about action potentials. Nervous system cells called neurons can communicate with one another. One neuron communicates with another by sending a message called a synapse. In order for this communication to occur, neurons must generate an electrical impulse called an action potential. Let's take a closer look at the neuron cell membrane. The neuron's membrane contains protein channels and exists at a resting membrane potential of about -70 millivolts. We say that the neuron is polarized. The protein channels allow for the movement of sodium and potassium in and out of the cell. There is a higher concentration of sodium outside of the cell than in. When the neuron is stimulated by a neurotransmitter, voltage-gated sodium channels open, allowing sodium to move into the cell. We say the neuron is depolarizing. The membrane is becoming less negative as positively charged sodium moves into the neuron. This continues until the voltage reaches the threshold, which for neurons is about -55 millivolts. Once the threshold is reached, many voltage-gated sodium channels open, allowing sodium into the cell. This causes the membrane voltage to change, reaching about +30 millivolts. The neuron has now generated an action potential. At +30 millivolts, the sodium channels close. Voltage-gated potassium channels now open, allowing potassium to move out of the cell. The membrane voltage returns to the resting membrane potential of -70 millivolts. Action potentials travel or propagate down the axon of a neuron until reaching the axon terminal. The axon terminal responds to the action potential by releasing a neurotransmitter. Action potentials allow neurons to transfer information throughout the nervous system. We hope you've learned something about action potentials, and see you next time.